Um, Good guys, welcome back again. Yesterday we have tried to integrate with Jira and we faced some issues. And for people who have not run the or not in the WhatsApp, they may not know what is the solution. So the thing is, when we try to convert to a base in 64 encoded string, we missed to add basic in the front. So that is the only mistake we did. So you need to add basic space and then username colon password and then convert them into a basic 64 encoder string. Okay, so this is the syntax and this is working absolutely fine. I have already tested this and let's try to run it. Okay, I already have started my Jira, so it should work. And more importantly, I will also added one configuration, rest assured.config. Again, this log config is a method where I'm adding blacklist header, which means I don't want to display whatever the thing that I have here in the console. Okay, if you notice, the authorization here is blacklisted and I am sending a new defect. Okay, creating a new defect, and the idea of it is I basically dem 11. Okay, so let's go and search in dem 11. Okay, let's try to log in. Okay, if you notice, we can go and search here. Okay, this is the project issue that we have created, and this is the summary and description that I have given. Yeah, for now, yeah, it is quite random, but still you can give your own stuff. Okay, so yeah, actually you can pass the failure stack trace here so that it creates a defect. You can also add attachment. You can also assign assignee. Okay, it's just that you need to uh, change the JSON file. That's it. Okay, so if you want to add assignee, you can also do that. I already done that in my office project. So you can go to JSONs where we had the dummy file. We had a file, right? So basically that's in request one JSON. Okay, so go here, and for assignee, if you want to add an assignee, you have to use something like this. Okay, and you can use key like assignee, and then you can give the name. Okay, their name here. Suppose your username is some name. Okay, you can give like something like this. Okay, so I have seen this syntax in their documentation. Suppose you want to add more fields, you can also add that. Okay, if you want to improve comments, you can also check out that. Okay, yeah, so basically it is working fine, and also we have understood how we can blacklist a header. Okay, apart from that, you can also blacklist multiple headers. Suppose I don't want to see the content type as application.json, you can also do that. Okay, it's not like you can do only one. So let's go to the auth demo, and here authorization is basically one header. If you want multiple, you can add a comma and then add um, so the content type, right? So basically content hyphen type. Okay, you can add like this. So it will also not display those values. Okay, so sometimes you are passing your bearer token in the header. Okay, you don't want to display that. So for security reasons, okay, you can blacklist them like this. Okay, it's a very simple snippet, so not much there to explain about it. Okay. Okay, this time if you notice, blacklisted content type is also blacklisted. Okay, so you can blacklist multiple header values like you want. Okay, so this is what pending from my previous class, and I hope I have covered everything related to framework design. You have a very neat framework. If you want to add test, you can go and directly add the test in the com.tmb.test. You can ignore these three classes. These are all just for our learning purpose. So we have a very good skeleton to build on top of it. So if you want schema, you can also integrate with that. Okay, you all already know about how to do it. Okay, so I'm not doing it. Yeah, so we have basically everything, annotations, your constants, your enums, everything. Okay, so can work on each of these. Okay, good. So we have already built the framework, but the problem is when you are trying to ship this framework, okay, as a Maven project or something, people are facing issues because you are using Java 11 and they are using Java 8. So some function, some methods and classes you use, they may not be present in the older version of Java 8. So that's the problem, and most probably they wouldn't have Maven installed or done the path configuration. And most of the company, okay, they will have restrictions to set the environment variables. So if you ask your clients to do all these things, install Java, set the path, download Maven, set the path, they will become very angry, and they will not be able to appreciate you. So what we are going to do, we are going to build a Docker image for our test automation regression suite, and then we're going to ship everything together. Okay, so let me close all these things. And for those who don't know Docker before, you should I would highly recommend to watch my Docker playlist, and I'll give quick highlights on what it is all about now. Okay, good. To first understand what is Docker, we need to understand what is virtualization. Okay, so let me take a break. And who already knows about it, virtualization? Who already knows about virtualization on Docker?
Even I have like idea.
Okay.
Virtualization, I don't know about Docker.
Okay.
Virtualization is basically like logical separation of the like
Yeah.
resource.
Yeah. Maybe you can use VMware. Okay. Some virtualization softwares to split your machines to host some other OS inside your host OS, right? So yeah. So we'll see that. Okay. So virtualization is basically importing a guest OS on top of your host OS. What does that mean? Suppose imagine you have your laptop, okay, that is sitting in front of you. That may be a Windows machine or a Mac machine or a Linux, and using the hypervisor that is sitting inside your machine, you can build another machine inside your laptop, okay, using virtualization softwares like VMS. Okay, what happens? Okay, what is the advantage? So you can able to run multiple OS inside a same laptop. So you don't have to, suppose your use for the Mac OS, okay, is very less. Okay, you don't have to purchase a separate machine, right? So you don't have to do all the things. Okay, you can use a VM software, you can create a new machine, you can install a Mac OS and then work on it, right? Suppose you need a Linux OS, you don't have to purchase a new machine. Okay, you can directly use VMware, install a Debian or a base image of Linux, and then Ubuntu, something like that, and then you can start using it, right? But the problem is, okay, whatever the memory you allocate to one OS, suppose let's say your physical laptop, let me use annotate tool. Okay, suppose you say your physical laptop is let's say 32 uh, GB, okay, of RAM, and 2 TB of HDD, okay, something like this. Now you want to run a Mac OS on top of this. Okay, it means you have to split this. You have to split this, and you have to, let's say you assume that you need 10 GB of stuff for this, and 500 GB of hard drive to work. Okay, then you are allocating this. It means you are taking the resources from your physical infrastructure and giving to this particular OS. The problem with this is, suppose this Mac OS is currently not using anything, okay, or not using the entire resource that you have allocated. Then in those cases, there is nothing much you can do. Okay, it still occupies 10 GB, it still uses 500 gigs of your hard drive. So this is the problem, right? Once you allocate, you cannot over allocate and you cannot under allocate. Okay, you cannot underutilize this resource. Suppose if it is requiring 16 GB of RAM, you are just allocating 10 GB, and it might not be able to run effectively, right? So that's the problem. So you need to have a right strike between what you need to allocate and what you have allocated, right? So again, the advantage is pretty much like you can run multiple multiple OS on top of a simple host that you can do, so that you don't have to purchase different machines, right? So that's what even AWS is doing. What their EC2 is all about. Their EC2 is a physical bare metal server. They are virtualization. They are using virtualization to build the different EC2 images based on your requirements. Okay, so what they are doing is they're basically allocating different memory and size based on our requirements, right? Good. Now this is what visualization is all about. Now let's also go one step further, and as I told, virtualization, you can run multiple operating system on top of it. Maintenance and recovery costs were easy. Suppose if there is a failure, something like that, you can again create a virtual machine and do it. Okay, but it's not like you if you are purchasing a new laptop, If something goes wrong, you have to go repair it, and it involves a lot of cost, right? And total cost of ownership are also less due to reduced need of infrastructure. Yeah, because you don't have three different machines. Instead, you have a big machine, one machine, and then you handle it everything, right? With the help of it. Most of the time in our companies, the virtual desktop that we take, right, we normally take a offshore, we take a client desktop, right? What we do, we're taking a remote connection of some machine that they virtualized and give it for our use. Okay, so disadvantages is like, sometimes it leads to oversubscription, so that your host may run out of resources, and the boot up process may take longer time. And since you are running OS on top of hypervisor, it may not be really like a machine. It may not really have a power like a machine, but it will have its own kernel and a set of libraries and dependencies. So suppose you are installing a Windows OS on top of another Windows, then what happens? The Windows OS that you virtualized now, you have to again install Windows, all the stuff. Okay, so you cannot cut any license cost. You have to create, purchase a new license, and then it occupies certain space. You all know, right? If you install a Windows OS, it requires at least some space, right? So it will be always there. Okay, that's a disadvantage. Now we understand what is containerization. Containers are basically an operating system virtualization. If you notice the diagram here, this is your physical machines, and you have your operating system. In my case, it's just Windows. Okay, let me use annotation here. So this is my laptop. Let's assume this is my laptop. Okay, and I have my OS on top of it, that is Windows OS in my case. Okay, using a container engine, there can be a lot of container engines, but predominantly people are using Docker. Okay, now on top of this, you have container one. This is your container one, C1, C2, C3. Okay, this is container one, container two, container. They all didn't have a separate OS. They all having are using particularly this particular OS. So that's what we call it as operating system virtualization. Yeah, they are basically built using Linux based images, but we'll come to that later. But they don't separately have their OS. Okay, they only have small kernels and some Linux utilities, so that it can run something. Okay, so basically these containers can be managed with your container engine. Okay, so suppose, let's say you are running a Chrome on this container, which means it will have all the necessary dependencies to run a Chrome. Okay, it will have all the binaries, executables, whatever okay you want, it will be inside this C1. In our case, we are going to build an image for our test automation. Okay, test automation suite. In that, it will have what and all things. It will have Java, it will have Maven, it will have our test suite. Okay, it will have everything it is needed to run the test. Okay, so this is what we are going to do. We are going to create an image and run it as a container, and it will have everything in it, so you don't have to worry about it. Okay, it is like, you are shipping. Suppose your people are sending couriers from one place to another. Okay, what they are doing, they're packing it in a way that everything is inside it, and then they're sending it along, right? If you're sending three different things to the same place, what do? You pack everything together and then send it. Previously, we are asking clients to install Java, Maven, and then test automation framework, run the test automation framework. Okay, and then there are a lot of issues because of different versions, different compatibility versions, issues with your Java and Maven, all those things. Okay, so what I'm going to do, I'm sending all of them together now, so that he can basically use use the entire container. Okay, good. So let me clear all the drawings, and let's also learn about the advantages. So you don't have a guest OS now, so the OS overhead is not there. So your containers basically utilize your host operating system. It will share relevant libraries and resources when it needed. Okay, if your container is needing more resource, it will pull it from the host. Otherwise, if it is not needing it, you don't have to allocate it. Okay, you don't need it. Okay, in case of virtualization, it's not the case. Okay, it has to allocate, then only it will work. Okay, even though you are using it or not, that doesn't matter. Okay, so the lightweight and faster than virtual machines, we all know, because containers basically don't have OS, all those stuffs. It's much faster. So we're going to see how it is. Suppose someone who already installed or ran a virtual machine knows how painful it is to install run your virtual machines inside your host. Okay, but containers are going to be really easy. So if you don't understand what I've spoken for the last 10 minutes, this diagram going to be very easy for you to understand. Okay. So on left hand side, you have your infrastructure. Using hypervisor, you can run multiple laptops. Imagine like this. Okay. These are all multiple virtual machines, right? One virtual machine, second virtual, third. But imagine these are all your different laptops. Okay. You're running different laptops inside your laptop, something like this. Okay. It's like almost renting a room. Okay, suppose consider I get a job in Mumbai or Bangalore. Okay, I need to come there. I need to rent a room. Okay, how difficult it is to find a room in Bangalore? You all know, right? So it's very difficult. You need to give advance, and then you need to go and set up all the things. Here, if you are setting up all the OS yourself, you need to install the OS yourself. You need to make sure that you are configuring all the parts and all the stuff. Okay, so same like that. Same like renting a room. If you rent a room, you have to give advance. You need to go and install or gas connection or all the stuff that you need to do yourself. But imagine on your right hand side, you don't, it's like a PG. Okay, you go, you tell the owner, okay, I want to be here for next 2 months. Okay, he tells, okay, pay me 5,000 for this month, next month 5,000. You're all done. Okay, you have your bed ready, you have your washing machines, everything ready, and then you can live there very easily. Same like this. Okay, containers are like that. Okay, very easy to spin up and spin down. Okay, we're gonna see about that. Yeah, for someone who's not aware of PG, they can imagine like Airbnb. When I was in Australia, we rent something. When we are going to some trip and all, we book rooms in Airbnb. Okay, so it's very simple. You go to someone's house and they give you a room to live for 1 or 2 days, and then you vacate. Very easy and simple process. Okay, and very cheap as well. Okay, good. So guys, this are basically stuff that I used for Selenium framework slide. So you might see some irrelevancy, but I'm only covering what you need. Okay, so suppose download Docker. How to download Docker? It's very simple, guys. It's like a normal software. So Docker desktop for Windows download. Okay, go here, download desktop for Windows. It basically downloads you one exe file. Okay, any doubts? Okay, I hear someone speaking. Okay, any doubts, guys, in whatever the topic we have covered so far?
Amuthan, I want to ask that, let's say I'm making containers on a machine, so that containers will also take up some space, like some resources from a machine. So there is a limit up to how many containers I can run, right?
Yeah. You can define
Okay.
the limit here somewhere. Okay, here there will be resources. Okay, previously it was there in the new features, maybe it's not here. Okay, but previously it was there, how much resources you want to allocate to this. Okay, you can basically do it in the Docker settings. Okay, but now maybe you have to do it via code, it seems. Okay, in the latest versions. Proxies, WXL integrations, no, it's not here. Okay, so somewhere here you can do it. So the resource allocation, you can define how much resource you want to allocate from host to containers. You can do that as well. Yeah.
And let's say I have my first container which contain app one. So if I'm adding 10 apps, so will it take more space? Like, will it make the container big and take up more space on my machine?
See, one container can have only one image. Okay. If you are adding 10 containers, yes, it definitely gonna consume some processes based upon what the operation it does. Yes.
Okay. Okay.
Okay. See, normally people are running their developer applications there. Okay, they're running their Apache server, Nginx server, whatever, and then they have your backends. Everything they're running. So Oracle databases, MySQL databases. Okay, their Elastic Stack, Logstash, Kibana, Datadog, whatever the software you name it, everything is available in Docker. Okay, so you install Docker, everything will be taken care. Okay, yeah. So basically, when development people are
So
running it,
Amuthan,
yeah, go ahead.
it's like, yeah. So like basically the purpose of this container is to like run some software, or like if for let's say in one container there is one image. So we download multiple software required for that?
See, one container can have only one image. So basically the runnable instance of your image is your container. Okay, um, don't worry too much about it for now. Just assume each containers are like a separate laptop. Okay, this laptop is going to have all the details or all the data that it needs. Okay, for example, in one laptop you're going to have only one Chrome browser. In our case, we are going to have one test automation setup. let's say in your company, what you normally do, they will have a separate machine to run the automation test for the entire company. Okay, what they do, they'll have a very big VM where the Java is installed, Maven is installed, and then what they will do, they will have their Chrome browsers, everything set up, and then they will ask people to run your delegate your test to this Jenkins node. We will take care of the remaining. Okay, correct?
Yes, Samutan.
Yeah, so they are spending a lot of money to maintain that infra. Okay, and most importantly, you can have only one version of Java and Maven at a particular point of time. So suppose different projects use different things, right? And sometimes they may not be even working in that particular that may work properly in their machine when they are running it, because they are using Java 11 with the Maven latest version, and it is working fine in their machine. When they are trying to run in Jenkins, it is failing because some of the method they are using from Java 11 is not available in that virtual machine, because they have installed Java 8. Java 8 doesn't have that method. Then what happens? Okay, then they complain. Okay, you don't develop a proper product, you are not developing good quality automation code. So this is the problem that happens, right? So what I'm going to do, we are going to build something of similar sort. We are going to have a machine that is going to have everything: Java, Maven, whatever the version we want, we will do it. Okay, we'll have everything installed. So just that you have to run it. Okay, so don't worry too much about it for now. Imagine your containers are lightweight VMs. Okay, you already know about what is VM. Lightweight VMs are a lightweight laptop that only one software. Imagine like that. Okay, so we're gonna see that in detail, so we have a lot of time to learn about it. Don't worry about it. Okay, so now install Docker for desktop. It's very simple process, guys. I have my YouTube channel also. I have explained this very simple exe file. You just need to check all the check boxes and then click on yes, 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 yes. It'll install that for you, and then you can run it. Okay, once you run it, you'll see something like this. Okay, and you may not be able to see all these things, but once you install, just go to your command terminal, whatever PowerShell or command prompt, whatever the terminal that you use, type Docker. Okay, once you type Docker, you might see something like this. Then it means Docker is installed. Okay, then understand what is this. Okay, and also if you notice, there will be an icon here. For me it's not displaying, but yeah, my Docker is up and running now. To make sure that it is up and running, type Docker images. Okay, so I have some images here, but in your case it not be there. It may populate you empty thing, but that is fine. Okay, now what I'm going to do. Okay, now let's assume you want to pull some code from GitHub. What you do, you type a git pull and then the git repository name, right? The same way these guys have something called as Docker Hub. Okay, in this Docker Hub only they have maintained all the images. Okay, guys, there are two worlds now. Okay, from here on. Okay, this is your normal world, software world, and this is your Docker world. Okay, this is software world, and this is Docker world. Okay, yeah. So Docker world and software world. Okay, whatever the things that we call in software world. Suppose if you want to install Chrome software, what do we do? We install this chrome.exe file. Sorry, we download it and then we install it, right? So whatever we call it as a software here is basically is an image in Docker world. Okay, so here you install a Chrome, you download a Chrome image, you install it, and then you work on Chrome. Here you pull the Docker image. Okay, and then you run it and then you work on it. Okay, so it's like very simple. Okay, you download the Chrome software, install it, and then run it. Right here, you pull an image from okay, you are pulling it from the repository or registry, and then you are running the image. It will create a container for you and then use it. Okay, so this is how what is the difference between these two. And in case of software world, we store all our stuff in the GitHub. Okay, we call it as repositories. Okay, Git repository, we call it as Git repo. Here we store everything in Docker Hub. Okay, Docker Hub, it is a registry. Okay, it's a public one. Okay, public registry. Okay, we call it as a registry. Registry is just a place where all the Docker images have been stored. Okay, let's go there. I have signed up with my account. In your case, you may not be there. Okay, so what I can do, I can basically search for, suppose I want to work with Oracle. If you notice, I'm getting Oracle database enterprise version. So instead of downloading a software in your, suppose if I want to work with Oracle, what we normally do, Oracle 12c version download. Okay, all these things we'll put, and then we will download it, and then we will install it. All the stuff is there. Okay, but in case of Docker, you just need to type one command. Okay, so they are telling, okay, this is a licensed version, so it's asking all these things. Okay, but let's take something else. Okay, might not be completely like this. Enterprise versions, these are all enterprise versions. Maybe I'll use something like Selenium Chrome. Okay, so if you, in case of Chrome, see, they are telling Docker pull Selenium standalone Chrome, which means just to download this image or pull this image. Okay, and then you can work with it. And most cases, in everything we'll have hello world, right? So hello-world. So hello-world is basically an image that is like software in real world. If you want to download this and use it, okay, you can use it. They are telling Docker pull hello world. Just copy this, go to your thing, and then enter it, enter. That's it. So it's basically pulling the hello world image from this Docker hub. Okay, so if you notice, I have already pulled this. So it's telling I have already pulled this image is up to date for hello world latest. But if you notice, there is something added before to this library hello world latest. Okay, I just typed hello world. What are these things? Okay, so library is basically who has developed this. Okay, all the Docker official images, which means, okay, people might get confused. Okay, if you go to download some movies, okay, in some torrent websites, what they tell, they'll have 100 links. You don't know which one is real one. The same way, if you just search for hello world, you will get 1000 entries. Okay, that's why people mention this is an official image. So you can basically understand this is created and maintained by Docker people themselves, so you can rely on it. Okay, if an image is an official image, which means the author name is library. But let's go to the Selenium example that we have learned before. If you notice, Selenium standalone Chrome, but the author is here is Selenium. Okay, if you go inside it too, okay, the owner is basically Selenium, guys. If you notice, the GitHub repository is also official repository they have mentioned here. So whatever that is mentioned before slash, that is author name. And if it is an official image, you don't have to mention the author name before it. Okay, but if you want to pull an Selenium standalone Chrome image, then you have to mention the Selenium here, otherwise it won't work. Okay, now at the end you have colon latest, which means that is the latest tagged version. Okay, every image can have multiple versions of it. Suppose you are writing your automation code, you are pushing to GitHub, okay, for the latest release. What do? You'll name it as a release August release 0.1. Okay, next to push you are doing August release 0.2. You are doing like that, right? Same way, the hello world may have multiple versions. In that, I am interested in latest tagged version. Latest tagged version doesn't mean this is the latest version. It is just the latest tagged. That's it. See, suppose people name there are people with name like Arivalagan. I don't know whether you understand Tamil, but Arivalagan means he's very skillful, he is very knowledgeable, and then he's also very beautiful. But they may not be the case, right? Their name is just Arivalagan, but they not be really talented or knowledgeable. So that's what I'm telling. So the latest doesn't mean it is the latest tagged one. Okay, latest one. It is just the version name is latest. That's it. People may use it for latest version, but that is not a confirmation like that. That's not a defined rule. Okay, it can be latest one, but it is not always the case. Okay, good. Now we have pulled this image and all the stuff. Now what we are going to do, we're going to create an image for our test automation framework, and then we are going to do Docker pull, and then this, and then if you want to run this, okay, this is just in software. You have downloaded the software. Now you have to install and run it. How to run? Okay, in Docker world, Docker run hello-world. Okay, Docker run and then the image name. Okay, once you do this, now this will run that particular image and it will do what and all stuff it needs to do. Okay, hello from Docker. This message shows that your Docker installation appears to be working correctly. Docker client contact the Docker daemon. Will come to this, but if you notice, it has actually done some work. Okay, this is the work their developers, the hello world developers, this image developers asked it to do. Okay, so it has done this. Good. Now let's go to the basics again. So this is the Docker engine skeleton. Okay, now we have understood what is Docker, and then we also understood what is virtualization, containerization. We also understand where they are hosting all these images, that is Docker Hub. Okay, who is author, what is version, okay, all those stuff. Now let's also understand integrally how this works. Okay, when I typed Docker pull hello world, what happening? Okay, this is my Docker client, guys. Okay, Docker is basically comprises of three things. Okay, one is your Docker client. Okay, it's a client server architecture. It has client and then the Docker daemon. Okay, okay, when we downloaded the Docker from Docker download for desktops, we are actually installing the server. Okay, so our Docker daemon. Okay, it is also working on client server architecture. Okay, let's also create one more. So this is your client, this is your Docker daemon or engine. Okay, Docker daemon or engine or server, whatever. Okay, now what are the commands that I type? Okay, I typed Docker run hello world. All these commands will be sent to this Docker daemon. Once you start this software, it will be constantly listening to all the Docker clients. Okay, whoever sending the request, this server will listen to it and then make the actions accordingly. Now when I type Docker run hello world, it basically sends this information to the Docker daemon as a REST request. Okay, as a REST, for those who understand REST API calls, may understand. Okay, it is send your REST API. For the tunnel is made using Unix sockets, but that's for a different case. Just assume, okay, just assume this is whatever the PowerShell or command prompt is our Docker client. We are sending some commands that is going to hit this particular server, okay, which we are actually running. Once it hits that, it does some operations based upon our instructions. Okay, so client is telling the instruction, server obeys, listens to it, and sends the response back. Okay, okay, now let's go here and understand. So if you notice, the Docker daemon is what we have installed and running, and we have Docker client, that is your command prompt. Whatever the request you are telling, okay, Docker container run, Docker pull, all these commands will go to Docker daemon via REST API calls. Okay, that's it. Very simple. Okay, only three components, guys. Okay, client, server, and then the REST API. Okay, now as I already told, software world, Docker world, there are two different world. In software world we call it as software, in Docker world we call it as images. We install and run the application. Here if we pull and run the application, it becomes a container. Okay, we store everything in GitHub repository. Here we store everything in Docker registry, that is Docker Hub. Okay, and then there is always this confusion. Okay, whether it is Linux or container, whatever the container you told, the container is a lightweight VM, whether it is Linux or Windows. Okay, that's what you're asking, right? That may be your question. Okay, there is no Mac containers and all. Okay, guys, if you notice this hello world that we have learned, maybe a Linux container. Okay, let's go back and then see. Okay, what is the base image they used to build that is what? So if you notice, it has Linux version and then the Windows version as well. So if you want the Windows version of hello world, you can also download that. Okay, but if you notice this one, Rancher hello world, this guy created one. Rancher is the guy who created this. Hello world is basically the the image. And if you notice, this is Linux, what he has done, okay, he has basically used some Linux subsystem to build this. Okay, this was built 3 years ago by this guy, and version is 0.0.1.2, and then there is okay latest version. There are two things. Okay, the size of this is 7.37. So basically, what is the image, what is the base image they have? Okay, suppose you are using Windows, means okay, you have to install a Windows OS. It involves license and other stuff. So most of the images are just Linux images. Just keep in mind, whatever we are going to build, the test automation images, they are also going to be Linux images. Okay, Windows images are very, very rare. Okay, so you can imagine that they don't exist, or you don't get confused often. Always, whenever people are referring, mostly 99.9% it will be Linux images. Okay, good. Now let's also go there, and yeah, so we understood what is the Docker. Docker is an open platform for developing, shipping, and running application. Okay, in test automation we have two use cases. If you're using Selenium, you can run your test on Chrome, Firefox, with or without Selenium Grid, or you can also ship your test automation framework as the images. In my Selenium automation framework, I have covered this, but now we are going to do this. We are going to build an image for our test automation suite, and then we are going to ship it as an image. Okay, so if you want to build a Docker image, okay, you have to write a Docker file. Okay, so suppose you want to build some development application, what do? You have to write a code in Java or Node.js or whatever the language that you want. So the same way, if you want to build a Docker image, you have to write Docker file. Docker file doesn't involve a lot of coding, guys. It's very plain English, anyone can understand, so it's very going to be very easy. Okay, and if you run that image, it becomes a container. You can push that image to a Docker hub and store it. Okay, good. Yeah, so this is all stuff we don't need, but let's see what is Docker images and how to build it. Okay, we already pulled one Docker image, right? How these guys would have developed this. Okay, how, that's what we want to going to understand, because we are going to develop our own Docker image. Okay, good. Now if you imagine, the problem we have is two. Okay, one, the Java, and we want to do Java, Maven, and then test all these things into one big block. Okay, that's what we're going to do. We're going to put all these things together in a single container. Okay, this is what we're going to do, but I need a one. Okay, let's go to Docker Hub. Okay, let's go to Docker Hub and then search for Java 1.8, something like this, because I am using Java 1.8. So I'm checking whether there is already Java 1.8 there. Okay, if you notice, there is a CJ Kang who has Java 1.8 image. Okay, which means if you download this image, it will have Java. This imagine this is an image or your laptop that will have Java 8 installed, all the paths set. Okay, but this is pushed to 3 years ago, and I'm not sure who is CJ Kang. Okay, so I'm not completely sure what he can do. Okay, so let's say I want to also search for Maven. Okay, let's search. Okay, let's search for Maven. I'm using 3.6.3, right? So Maven. Okay, this is an official image, so I can rely on this. Okay, let's go. So it is telling, hey, you're looking for Maven, which means I already have a lot of things with me. 3.82 JDK 11. Suppose you want a JDK 11 installed, and if you want a system that is having JDK 11 installed and 3.8.2 of Maven installed, then you can pull me. Okay. Okay, so there seems to be a lot of versions. You also have OpenJDK. Okay, you might also have JRE versions, everything. Okay, whatever. So these are all basically different versions. Okay, as I already told, these are different tags, which basically indicates what they really hold. Okay, if you want to work with version 3 and then JDK 11, then Maven version 3 and JDK 11, you can build this. Okay, so there are a lot of things. Okay, if you want to work with OpenJDK, then you can do this. Okay, but in our case, I already had that image with me. Okay, this is the base image that I am going to use. I actually removed it. Okay, okay, let me actually go to my GitHub repo. I have already experimented with certain base image, so let's go and get that. So I am using this. Okay, from Maven 3.6.3 JDK-8. I don't know whether this will be there listed here, but okay, this is not here, but let me go and search. I don't know, maybe this might be archived, but yeah, I'm using this. Okay, so if you use Docker pull and then you mention this, it will pull all these things for you. Okay, I'm using this from Maven repository only. Maybe this might be archived, but let me try to pull it and then see what's happening. Docker pull. So this is what I'm pulling. So this Maven colon 3.6.3. Okay, let's see what's happening. I already have this image in my local, so it should work. You can also try to pull different one. So it's already exists. It seems it's already exists. It is coming from library, which means it's an official image. I'm trying to use Maven 3.6.3 and JDK 8. Okay, this is the version that I used, and I pulled all the stuff. So which means I have downloaded that software. Okay, in my machine. Now I can use this. Okay. Now if you run this, it'll start a laptop with JDK 8 installed, 3.6.3 of Maven installed. But I also want my test to be there, right? So that's for that only we are going to write some Docker file. We are doing some logic. Okay. So now let's go to the IntelliJ. Okay. Now we are going to build our Docker image. Okay. For that, you need to create your own Docker file, guys. Okay. Click on new, click on file, and then maybe for now I'll rename this to something else. Okay. Maybe refactor, rename, and Docker file 1, 2, 3. Okay. Something like that. Now, whenever you are creating a Docker file, okay, you need a Docker file to build an image. Okay, I am creating a Docker file. The name of it should be always Docker file. It cannot be Docker file 1, 2, 3. It cannot be Amudan. It has no extension .txt, .json, no extension, just a Docker file. That's it. Okay. Now I'm going to create a Docker file. Okay. On what machine you want to create? Okay. What is your base image? I want a laptop that is having Java and Maven already installed. Okay. That's what we have learned, right? So my base image is this Docker pull Maven : 3.6.3. Okay. JDK -8. So for that you have to mention the from command. Okay, there is different commands. Okay, from, this is the one. Control is, sorry guys, it should be Maven hyphen. Okay, I will type it manually. So Maven : 3.6.3. yeah, 3.6.3 and hyphen JDK -8. Okay, hyphen JDK -8. So this is my base software. This is my base laptop that is having Java and Maven already installed, and path is also configured. Okay. Now on top of this, I want to add my test automation folder. Okay. Imagine most of my tests are inside the SRC folder. So I need to actually move these files. Okay, SRC main Java, SRC test Java, SRC test users. So basically this whole SRC folder, and then I also want my pom.xml, testng.xml in order to run my test cases. Correct. So I need to move this to the Docker image. Okay, so you can either use copy command or and then you can use like this. Okay, so what I can do, I'll copy this whole stuff and then I will explain it one by one. Okay, so this is the base layer. On top of it, what I'm doing, I'm copying all the contents that I have in the SRC folder to the folder inside my container. Okay, that is also a machine, right? That machine will also have folders. I am creating my own folder, that is home dash. This is not Selenium framework. This is maybe API framework. Okay, I want to create a framework folder structure like this. Again, you can directly put it onto the root folder, but that is not a good approach. For security reason, people don't do it. So always create some folder structure like this. So I'm creating an home API framework, and then inside that I pasted that. Same way, suppose you are running your test inside container, you want to get the result back, because we want the results in index.html. So whatever you generate in the folder in the index.html, you send it back to this guy, index.html, in my local host. Whatever you see here is your machine, your local machine. Whatever you see here is your laptop that you are creating now. It's your container. Okay. So third one, I want to copy the pom.xml to the folder. Okay. In the container home API framework, inside that you put this. And same way, I'm copying the testng.xml, I'm putting it inside that particular folder. Now, at the end of the day, I'm setting my working directory as like home/Selenium framework or API framework. Here, API framework. Okay, which means it's like you are opening your command prompt. Okay, you're opening like command prompt, and then you are doing CD, and then I'm going to a particular folder. Okay, something like this. Okay, you're going inside a particular folder, right? It's like that. You're going to that particular folder, because if you want to execute Maven clean test, okay, you need to go to the folder where your pom.xml file is located. Okay, first let's try to check whether our pom.xml what is it having, what is the file it is running, everything. Okay. Now my pom.xml is having Maven SurePlay plugin, which will in turn call testng.xml. Testng.xml, I have commented out all the test case and only included the assignment test. Okay. Suppose if I go to the terminal now and if I run it, Maven clean test, okay, it basically runs my API test cases. Okay, there is a build failure because I haven't started my JSON server. Okay, okay, if I start it, it will work. Again, this time while starting, we have to be very careful with the cost. Okay, let's start this. Users test JSON server. See, every time what we do JSON hyphen server hyphen watch db.json. Okay. Now this will create localhost 3000. This was working fine. Okay, that's all good. But now we need this local host in the terms of IP address. Then only someone else can contact this, right? I need a public DNS and to work with it. Okay. Suppose somebody wants to run their test, this which is actually how to execute in my machine. Then actually I need to give them the IP, right? So this local host doesn't indicate anything. If you are running this in your machine, it will be local host. In my case, I want to change this to IP so that my Docker container can understand this. So if you have to convert this to an IP, okay, my machine IP is basically IP config. My machine IP is this. Okay, I want to convert this local host into an IP. So let's see whether it is working. Okay, let's go here. All this time we were only telling local host 3000. It is printing this. If I type my IP address, let's say 192.168. Okay, this is the one. Okay, let's try to run it. So if you notice, the site cannot be reached. Why it cannot be working? So see, this is the problem with JSON server. While starting it itself, you need to tell, hey, I want this to be running on my host. Okay, I want to define my host. Then you close all these things. Okay, and then go to the JSON folder again. Okay, JSON server folder, and then this time while running it, okay, JSON -server -host. You mention the host. In my case, I'm giving my IP. Okay, 110. Okay, and then -watch db.json. Just checking whether my IP address is correct. Just a minute. 192.168.0.110. Okay, now if you notice, the URL itself is telling 192.168. Now let's go there and check this is working. Now you have converted the local host into an IP address. Okay, so that anyone can contact this. Okay, you can also use localhost 3000. Okay, now but now we are converted this to IP address so that any someone from external world can also access this, because Docker containers are again like a different laptop. You are accessing a different laptop from another laptop, right? So you cannot use a local host. You need to convert into a public DNS. So I have done that, and I also made the changes. Okay, here. Okay, if you notice, if I go to the src test resources config.properties, I have converted the base URL that previously we had just localhost. Now I converted this into IP. Okay. Now once we are done with this, okay, let's try to run the test again with the Maven clean install and check whether it is working. Okay. Okay, now this is working. So we are sending something and we are getting back. This is the assignment that we did, right? Very complex use case. That is working fine. And if you notice, this is a request URI. Okay, instead of localhost, you can also mention the IP. That doesn't matter. Okay, good. Now we have done everything. Now we need to build this as an image. Okay, for that there is a command that you can run. Okay, you can open terminal in your IntelliJ like this, or you can basically open a terminal outside of this and then go to this particular folder. Anything, whatever you feel comfortable, you can do it. Even from here, you can access Docker commands. Okay, you can do all the Docker commands. Now what I'm going to do, I'm going to build an image for this particular Docker file. Okay, this is a Docker file. You know what we are doing? We are having a base laptop. On top of it, we are copying all the files that we have from here to here. And this one, the index.html alone from there to here, because after executing the test, it has to, we have to see the results. So it's like volume mapping. Okay, whatever you have in this directory, it will also be there in this directory. Okay, same way we are pushing this code pom.xml from here to there. Okay, very simple. Okay, at the end I am running the maven clean test, so it will run the test and then give the results for us. Before that, we want to build an image for this. So for building an image, you have to type docker build. Okay, now what is the name you want to give? -t is for tagging. Okay, I have mentioned -t here, guys. It's like little light, so you cannot see. -t is for tagging. I want to my first image, and then the version is, let's say, 1. Okay, so this is a image that I want to build. Okay, you want to build this image. What is the docker file you want to use? This docker file is in the current directory, which means dot. Okay, I am in API automation framework folder. You pick the file that is docker file present in this particular location, that is in the current directory, and build a docker image for that with the name of my first image :1. That's it. Click on enter. So basically, in my case, it took very less time because I have all the necessary image layers with me. So it basically created for me. Okay, now if I want to run this, okay, you can go to your command prompt terminal or whatever. Now if you type docker images, it will list you all the images. So we have downloaded the hello world. We also downloaded the maven repositories. All these things are here, and also that my first name with the tag of 1 is also here. Okay, it's of size 525 MB. Now let's try to run this and then see whether our test is getting executed or not. Docker run image name is my first image :1. That's it. Let's try to hit on enter. Let's see whether it is running. See, it is running, guys. So it's downloading all the maven repository for you. So we are telling maven clean test, right? That is basically a different machine. That machine doesn't have all the dependencies, so it is downloading all of them for you. Okay, even you can run this. Okay, anyone can run this. It will download and then it will start the test. Maybe it take a little bit of time. Okay, but yeah, so in the meantime, while it is downloading, you see it is downloading all the Lombok plugins, FreeMarker, whatever, external reports, everything, all the jar files. While the time it is downloading all these maven dependencies into the container, you can ask all your doubts. Any doubts you have?
Amudan, I'm like a little bit confused between the term image and Docker. So like whatever we have made now is an image,
Yeah.
and when we are going to give it to our client, so we'll give it as a container.
No,
right?
no. We are going to give them as a image only. When you run an image, it becomes a container. That's it. Okay.
Okay, so we ship the images, right?
We ship the images. Okay, when they run it, it becomes a container. Okay, suppose we have classes in Java. Okay, you create an object for the classes, it becomes objects, correct?
Yes.
Same thing.
And Docker is platform, right?
Docker is just the platform. Docker is the container engine that manages different containers. Okay, got it?
Okay.
Good. So basically this will be like, it will be like a layer. Okay, first you have, suppose imagine you are building a sandwich, okay, or a burger. So you have your base layer, the bun, whatever the bun you want, and then on top of it you add some cucumber, whatever, lettuce, whatever the stuff you want, and then you add some meat on top of it. Okay, again you add some onions or whatever you want, and on top of it you again paste the bun. So it's like a layer. So first you have this layer, then it will have this layer, then it will have this layer. If you notice, first it having this layer from library, it is trying to pull this. Okay, since it's already there, it went to the next step. The next step is you copy the src folder from the current directory and put it inside the container. Okay, so this is a second step. Third step, this is like images. Okay, these are all step by step. Okay, you build a multi-level apartments where you build the ground floor, on top of it you build one thing, on top of it you build another. Okay, so something like that. Okay, after building 6 by 6 steps, okay, now it exported this to an image with the name of my first image: 1. Okay, Now let's go here and then check what is happening. Still it is downloading this. Okay. If you notice, okay, it worked. Okay. If you notice, after downloading all the jar files, now this time it is sending a get request, it is validating all the stuff, whatever the console logs it has, it printed all these things. At the end, the total rest run is 1 and pass is also 1. So you don't have to do anything. It can do all the things by itself. But there is a small problem here. Anyone can understand what is the problem? What is the problem with the image that we build now? Anyone can know what is the problem we have?
Like the reporting part is like visible on the prompt only. We don't like extend report. Not.
No, extend report, we can suppose we have run the test now, right? It would have shipped that in the index.html from the container to the outside index.html in the current folder. Okay, if you go inside it, you can also view the index.html. Okay, this is the one that it ran now. Okay, so you can also see what is the time it started, 7:52 a.m. This is time. Okay, all those reports. Okay, everything is there. It's all good. But the problem here is, okay, every time you run it, it downloads all the dependencies. Okay, so basically downloads a lot of stuff for you. Okay, again, if you're someone who is convenient, okay, I'm okay, let it download, I don't mind. Okay, then so that's fine. But there is a better way to handle this. Okay, what is that? Now, if you notice, we go there again. Okay, now I type docker ps, which means, okay, it will check what are all the containers that are in running state. Now I'll also tell docker ps-a, which means it will tell all the containers that are in running state or stopped state. If you notice, this is a my first image one. This is a container it created, it ran, and it created 4 minutes ago. It exited 2 minutes ago, and the name of it is nostalgic Da Vinci, whatever. Now this container is basically having all the Maven dependencies. Okay, I don't want, whenever I try to run it, it will again download all the Maven dependencies. I don't want to do that. But if you notice this, whatever the laptop, the container that we created, this container is having all the Maven already downloaded in it. So what if I convert this into a base image for my test cases? Okay, so that's what we are going to do. So this is a container. I want to create an image on top of it. Okay, guys, we have a container. Okay, we have a container now that is having Java installed, Maven installed. Okay, also test framework. Okay, test framework in it. Okay, and also Maven dependencies also installed. Okay, so you don't have to download the dependencies and stuff. Okay, because it will take 2 minutes to download the dependencies. I don't want that to happen. I also now I have a container that is having all these things. Now I am converting this back to image. Okay, how can I do this? Okay, for that you just type docker commit. Okay, I'm going to commit this particular again, guys, nobody teaches you all these things because this is very tricky for people who are starting. But yeah, this is one time efforts, right? So you can learn it. Okay, and then you can mention 945 ACE, some 3 or 6 letters so that it can uniquely identify that. I want to commit this. Okay, okay, you want to commit. Now this is now writable. You can write or do some changes on top of it. If I type docker images now, okay, there is a none image, which means there is no name for it, but there is an image here. Okay, you can now name this image. Okay, for naming the image, again, you can use docker tag, or you can directly use docker tag container id and the image name directly, whatever. Okay, now let's go here and let's type docker tag. I have a container that is called as this, okay, 945 yes 945 ACE, and I want to tag this none image to that. And the image name that I want to create now is let's say Amudan QA. This is basically my repository Docker Hub account, my author name. Now on top of it, what I'm going to do, Java 8 Maven 3.6.3, and then I also have MVN dependencies or test dependency. Okay, maybe test dip. Okay, some short name. I don't want that to go big. And the version is, let's assume I want to create it as a one version. Okay, this is the first version of it, or you can also name it as latest. So no such image. Okay, So it is telling you cannot find this thing. Okay, let me, so 945, instead of that I want to name this image ID is basically FE. So the image ID is here. Okay, FE9F5. Okay, straight that. No tag.
The FE.
Sorry. Oh, FE. Okay, sorry. FE 9F. FE9F5B. Okay, FE9F5. Now it has done it. Now let's do Docker images again. And if you notice, this has now been named as this and latest. Okay. Now this is going to be our base repository. Okay. Let's go here, and thereafter we don't need this because this does not have Maven dependencies installed. So what I'm going to do, I'm changing my base repository now. That is Amudan QA. Okay. Amudan QA / Java 8 hyphen 3.6.3 3.6.3 hyphen test dependency something. Okay, this is basically my base image now. Okay, now let's try to build an image. Okay, right, let's try to build an image, and this is my okay final image. So I can basically name it very well. So this name it as Amudan QA and then /tests or API test image, something like this, /latest. Okay, I'm building a new image. Okay, so I didn't pass to which folder the Docker file is located. It is in the current folder. Okay, I'm building it again. So now it has builder. Okay, let's go again to the command prompt and then do a CLS image Docker images. Okay, now if you notice, there is this particular image which I'm pretty interested because these are old images. Okay, this is a new image that has been built from the base of this, so it won't download the Maven dependencies. Now let's try to run Docker run and then Amudan QA /API test image. Okay, /latest. Okay, this time it should not download the Maven dependencies. Okay, so if you notice, it's already started to run the Maven compiler plugin and the Surefire plugin. Your test is now getting started. Okay, so it is sending all the get calls, doing all the stuff for you. Okay, now there is a failure because maybe some reasons, but yeah, expected was 197 but was 196. This can happen when you are making a post call. If you generate a random integer, we are generating a random ID, right? When you are generating a random ID that is already available, it may fail. So this time if you want to run it again run it. That's it. But this time it's not downloading all the stuff for you. Okay, that's the beauty about it. So now this is passed. Okay, so yeah, basically you can use this. Now you can push this to the remote repository. Now normally we work with Git, we're coding everything, but we need to push it to a GitHub repository, right? So anyone can work it. So the same way I can push it. For that, I'm using first CLS. Okay, now first you need to tell Docker login. Okay, in my case, I already have registered what is my username and password. It's like Git login, right? You do Git login where you mention your username password. Same way I have done it. In your case, it will ask you for the username and password of the Docker Hub. You create your own username and password in Docker Hub, and then you give it. And on top of it, what I'm going to do, I'm going to push it to the remote. Okay, Docker push, and then where you want to push it. I want to push it to Amudan QA, and okay, this is the command, guys. Okay, Docker push, and then the image name. So maybe the image name I want. So for that, I can tell Docker images. Okay, Docker push. So it is pushing all the stuff. So I already have a base image in my repository. So some of them, the layers which are already available, it is taking from that. Okay. I know I'm going a little fast, but this should be fine. Okay. Because you have 2 days to practice and then you can ask your doubt. So I think it is now pushed. Let's go to the Docker Hub and go to my account. So this is, guys, this is it. So we have pushed our Docker image here, Amudan QA / API test image. Okay. If anyone wants to use this, okay, you can just type Docker pull and then you can pull it and then you can run it. Okay. If you just type Docker run Amudan QA API test image, it will run your test in your particular machine. Okay. Good. So that's all about it, guys. With this, I'll also take 5 more minutes to cover certain diagrams so that you can easily understand certain things. Okay. So the Docker image, okay, we are speaking about Docker image, right? It's a collection of a lot of files and metadata. Okay. So if you notice, this is the base layer, that is your Linux kernel and other stuff. Okay. On starting a container, you will get all these things. On top of it, you have your base image. In their case, they are telling Debian. In our case, we used Java Maven 3.6.3. On top of it, you can add your layers. Okay. They are telling add Apache, add Emacs, whatever. But in our case, we moved some files from here. We added SRC to the SRC there. We added some testng.xml from here to there, all the stuff, right? Now, this is how an image looks. Okay, it's like a layers, one by one. First, you have your base layer. On top of it, you add something. On top of it, you add something. Okay, it's a made of stack of immutable layers. These are all locked, which means they are not changeable. The base layer is not changeable. If you want it to be changeable, then you have to do a commit, you have to remove, or you have to write your own logic. Okay. Now, suppose if there are multiple images sharing same base OS, they can do it. Okay. So you don't have, it will not download the new image. Okay. So this is what it is. So whatever in the blue is one image, base OS of Debian, add Apache and configure files. Second one is Debian, Nginx, Node, NPM. This is another image. Okay. So basically, whenever you are adding, so whatever the command you are adding, right? So on top of it, you add this, which means this is an immutable layer. On top of it, it will create another immutable layer. Now this will become an image. On top of it, this will add one more thing. So this will become another image. Okay. This will become another layer. This will become another layer. And then lost after everything, it will become one, big image. Okay. One big image comprising of different layers. Okay. It's like imagine you are making a sandwich. Okay. Or a burger. You have a base bun. On top of it, you add different stuff, right? The same way. Okay. So yeah, terminologies, you can go through it, but there are three ways to create an image. One among them is what we used. We committed the container. We typed Docker commit and then the container ID, and then we created a new image layer on top of it. Okay, other layers are okay. You can create using a Docker file, and this is Tarball. You don't have to worry about it for now. Okay, and then we use Docker commit and then the container and then the name. Okay, this is all we did, right? So you have also used Docker pull. Again, Docker run is almost like you're creating and starting a container, so you don't have to use this. We have also tagged our image with a new name. We also pushed our image. You can also pull your image. You can pull my image and then you can run it in a Docker. Okay. So these are all difference between the image and the container. So image is basically read only system. Okay, you cannot do anything about it because it's a immutable layers. It consists of all the immutable layers. Okay, container, if you create a container, you can do some commit and then you can change it. Okay, that's what we have already done. So there are some commands like add command. We have done all these things, right? We have used copy. You can also use add. That's also fine. From is also a command. Work directory is also a command. You can also mention who is the maintainer. Maintainer is basically Amudan. Okay, something like this. So you can also maintain. These are all different Docker file commands. Okay, but yeah, I feel this is irrelevant now, so I didn't do it. Okay, there are a lot of commands, but for now you can think about only the commands that I mentioned. And yeah, Docker file is what we have created. Yeah, you can use Docker image build -t and then the name of the image and then the dot means current working directory. You have a Docker file, you use that. Okay, so this is what about there are different commands about it, but yeah, this is what you all need. Any doubts so far in this, whatever we have done? See, the ultimate aim is we don't want people to mess with the different versions of Java and Maven and all the stuff. Now we have pushed the code to the Docker Hub. Okay. Now now your client can go to his, if you install the Docker, he can go to his command prompt and he can simply tell Docker run this particular thing. Okay. In my case, I have named it as Samudhan QA. Okay. Okay. You can just tell Samudhan QA / API test image colon latest. Okay, that's it. If you just run this command, it will execute the test for him. In the current directory, he will also see the index.html. That is the reports. Very easy, right? It's very simple. So that's what you have to also do. Okay. We solved all the problems. Now anyone can do it. Again, the process of converting. So here we are manually typing the Docker file. Every time you make a change in your code, you have to build a new image for this. Yeah. But instead of that, you can push the code to GitHub. Okay. You can create a Jenkins job and then a Jenkins file, which basically reads also the latest code, build the image on top of it and push it to the Docker Hub. You can create a Jenkins job like that. So every time you commit a code to your test automation repository, it pulls the code, it builds an image, it pushes it to the Docker Hub. Okay. And then anyone can use it. Okay. That's it, guys. Okay. Any doubts? Any doubts?
No, Matan. This is
Okay.
looking good. Like,
Thanks for telling a valuable concept.
Yeah. So this may, if you feel little difficult, okay, I always have the test automation framework playlist in my, I think SK has already pointed this playlist. Okay,
Yeah,
Docker videos are starting from 42. Okay, I have slowly explained what is virtualization, containerization, different Docker commands, what is pull, what is run, what is create, what is start, everything. Okay, in this videos, just go through over it, and then you come to this place. Then you can understand more than this. Okay. Just search for Docker playlist in Selenium automation. Docker playlist testing many bytes. That's it. Okay, I have a separate playlist for Docker also. Okay, so you can learn from there. Good. That's all from my side. If you guys have anything, I can take questions or we can rock. We can take break for 2 days. You guys can practice this. And Tuesday we'll start with Spring Boot. Okay, REST API development using Spring Boot. We'll go for 3 to 4 days or 2 to 3 days, and then that's it. After that, yeah, you all have you are free to attend any interviews. You can clear all the interviews, I'm sure. Okay. Any doubts before we wrap?
This is not related to Docker, so I have some basic doubt.
Mhm.
So when I try to pass through some response, right, I'm facing some issues, so I'm not able to pass through any JSON using JSON path. So
Okay, just a minute. I will stop the recording. Okay.